Okay, we have to another integral. This one's from the UNSW Integration Bee 2024, problem 10. We have the integral from 0 to 1 of x natural log 1 minus x dx. Okay, I know a couple ways to do this anyway. The first one would be just to go straight to integration by parts, and that probably is more efficient. I don't know, but what I like to do on these is I usually like to transform it and do a u substitution first, just because I don't really like dealing with natural log that much. It's just kind of a personal preference. So I'm going to make my u substitution for natural log 1 minus x. And what I want to do here is I actually want to solve for x, so let's rearrange it. We can have 1 minus x equal to e to the u. Then adding x on both sides, reversing the sign, we end up with x equal to 1 minus e to the u. I'll take a derivative on this to get my dx value. So for dx, this is just going to become minus e to the u du. And now we can go ahead with this substitution. So plugging 1 in here, natural log of 1, that's going to happen when we're going to minus infinity. Plug a 0 in here, natural log of 1, that's just 0. For our x value, we have this over here, so we have 1 minus e to the u. Natural log 1 minus x, that's just u, and our dx is going to be this thing over here. But then I'm just going to take this minus sign here, and I can use it to reverse the bounds, or to swap the bounds, so we'll do this. Now let's just distribute in this e to the u and rewrite this, so our bounds stay the same. This here is going to become e to the u minus e to the 2u. Here, we'll just bring all this stuff down. But now that we have this in the form of like two functions, what I can do on this is integration by parts. We'll use the DI method or tabular integration over here on the right. I'm going to differentiate u, and then we'll integrate this thing. You could break it up into two integrals, but I don't really like to. We'll just do it this way. So then coming down here and differentiating on the left side, derivative of u, that's just 1. Derivative of 1, that's going to be 0. Integrating here, we get e to the u minus e 2u over 2. Integrating one more time, we have e to the u minus e 2u, need to bring another 2 out, and then we have a 4 here in the denominator. Now the last row's got a 0, so we don't have to worry about integrating that. We just can go to our solution here on the diagonals. Let's just kind of copy everything down. So we're gonna have u times this stuff here, and then here we have the minus sign. This is going to become minus e to the u plus, distributing in the minus e 2u over 4. And we need to evaluate all this from minus infinity to 0. But now just notice when we evaluate minus infinity, this piece is going to 0 and this piece is going to 0 because these are exponentials. Then over here, this is going to 0, this is going to minus infinity. Technically, we should do a limit for an indeterminate form here, but really because the exponential is going to be so much stronger going to 0, so much faster, the 0 is going to win, and so everything's going to be 0 for this minus infinity value. So now just evaluating at 0, this whole first piece is going to be 0 because we're plugging in 0 there, and this is going to be just some finite number. So that part's going away. Evaluating 0 here, we get minus e to the 0 is just 1. Then here we get another e to the 0 over 4, so this is going to become plus 1/4. Putting this together for my final solution on this, we just get minus 3 over 4. Okay, there you have it. Good one from UNSW 2024. Thanks everyone for watching. Have a good day.